Welcome to lesson 11. So today we're going to be talking about reciprocals and multiplicative inverses. So maybe to start, I'm just going to start by saying when we talk about the reciprocal and the multiplicative inverse, they're actually the same thing. So when we look at the reciprocals, they're also equivalent to a multiplicative inverse. They're just two names for the same thing. But it's a little bit easier to start by thinking of them in terms of reciprocals. So to begin with, we're going to backtrack a little bit, and we're going to talk a little bit about the additive inverse. You learned this a couple lessons ago when we were talking about inverses. So today we're going to be, eventually here, we're going to be talking about multiplicative inverse. Let's first start with reviewing additive inverses. And remember, if I asked you, what's the additive inverse for a 3? Can you remember what it would be? Well, hopefully you recall that the additive inverse for a positive 3 is a negative 3. That's the inverse. The additive inverse for a negative 4 is a 4. The additive inverse for a 7, positive 7, would be a negative 7, right? It's just the opposite of the number. So a positive 3, the additive inverse is a negative 3. We just change the sign, keep the number, right? And remember we talked about what happens when you add additive inverses together. So if you have a 3 and you add it with its additive inverse, which is a negative 3, remember you end up with 0. And that's true for every additive inverse. So if I start with a negative 4 and I add to that its inverse, which would be a 4, a negative 4 plus a positive 4 is 0. And same thing with the 7. If I have a positive 7 and I'm adding to it a negative 7, I have positive 7 plus a negative 7 is a 0. So whenever we're talking addition, and for reasons that you'll find later, it's always nice to be able to get numbers back to 0. And there's a process by which we can do that, and that's called the additive inverse. So in addition, it's nice to get it to 0. How do we do that? We add the inverse to it, the additive inverse. All right, so the additive inverse, we just change the signs, keep the numbers. Now in multiplication, when we're talking the multiplicative inverse, the multiplicative inverse, it's a little bit different. So if I have well, before I even say that, let's just point out the difference. So when we're talking the additive inverse, we're always trying to get back to these zeros. That's the goal, to get back to the 0. In multiplication, it's actually nice not to get to a 0, but to get to a 1. So we're going to try to get to 1s, all right, when we're dealing with the multiplicative inverse. In the additive inverse, we're trying to get to a 0. In the multiplicative inverse, we're trying to get to a 1. All right. So if we have the number, let's use the number 3 again, and we want to multiply this by some number to get to this 1, how could we do that? Well, the answer is to think of this 3 in terms of a fraction. So how would we write 3 as a fraction? Maybe you recall it's 3 over 1. All right. We're going to multiply this by something that's known as the reciprocal of the fraction. And when we talk about the reciprocal of the fraction, all we're doing is reversing the order in which we write it. We flip-flop it. So instead of writing it as 3 over 1, we write it as 1 over 3. Okay. This is the reciprocal. So the reciprocal of a fraction is just the fraction, oops, helps if I can spell, reciprocal is just the fraction upside down. All right, so just as kind of some examples here. If I take the fraction 3/4, what's the reciprocal of 3/4? Answer, 4/3 is the reciprocal. What's the reciprocal of 5/8? The answer is 8/5. The reciprocal of 1/2? 2/1. How about the reciprocal of a whole number? Let's say the reciprocal of a 6. Well, before we can write the reciprocal, again, we have to think of this in terms of a fraction. As a fraction, this would be 6/1. So the reciprocal is 1/6. The reciprocal of 59. Well, first write it as a fraction, 59/1. Then write it as the reciprocal, 1/59. All right? So all of these are the reciprocals. Oops. Oh, I can't fit all that in. Well, reciprocals of these fractions. All right, so these are the reciprocals for these. Okay, this row here, or this column. All right, so getting back to this, again, our goal is to try to take a whole number and somehow get it back to a 1. And in this case, we're discovering that we're going to do that by multiplying it by its reciprocal. So we have 3/1 times the reciprocal, 1/3. What is that going to give us? Well, this cross cancels. 3 can go into itself once, 3 can go into itself once, 1 on the top, 1 times 1 is 1, 1 on the bottom, and 1 times 1 is 1. And we end up with, lo and behold, the 1, which is what we're trying to get to. Okay? Because once again, I want to make sure you understand this. The additive inverse, we're trying to get to the 0. In multiplication, we're trying to get to a 1 when we're using inverses. All right? It's kind of important to understand that. This is going to be very important when we start talking about equations. All right? So let's try another one. If I have the whole number, let's go with the whole number 9. All right? And I want to find the multiplicative inverse of 9. What's it going to be? Well, the answer is 1/9. That's the multiplicative inverse for a 9. All right. How do we know that? We know that because if I were to write this as a fraction, 9/1, and I multiply it by this 1/9, we're going to end up with 1, which is what we're trying to do when we're using the multiplicative inverses. So what's the multiplicative inverse for 9? The answer, 1/9. All right. So what's the multiplicative inverse? Let's try a fraction. What's the multiplicative inverse for 3/4? And again, to find the multiplicative inverse, we just think reciprocal. We think these guys. What's the reciprocal of 3/4? Oh, it's 4/3. We flip them around. So 4/3 is our answer. That is the multiplicative inverse, or the reciprocal, of 3/4. And again, how do I know that? Because if we multiply these out, the 4s will cross out, 3s will cross out, and we end up with 1/1. Whoops. 1/1, which of course is 1. Right? So whenever we take a whole number or a fraction, any real number for that matter, any real number, and multiply it by its reciprocal, we get a 1. And again, we can say that as if we take any real number and multiply it by its multiplicative inverse, we get a 1. All right? Either way of saying that is fine. So reciprocal, multiplicative inverse, they're the same thing. Okay? So if in the homework sheets they ask you, find the reciprocal for 1/2, what would your answer be? Hopefully you said 2/1, or you could say 2, because that can be reduced. That would be the reciprocal for 1/2. if I asked you to find the multiplicative inverse for an 8? What would the answer be? Hopefully you said 1 over 8. Because we just simply write this 8 as a fraction and then flip it. That's the answer, 1/8. That's the multiplicative inverse, or the reciprocal. And again, just to specify, if we take any number, any real number, take your pick, we'll call it 3/4, there's our real number. If we take any real number and multiply it by its reciprocal, which in this case is 4/3, we should always get 1. All right? Very good. All right, so let's move on to one other piece of the puzzle here, and it has to do with something that we've learned in a previous lesson. What if we have this oddball one? What if we have 0? And I say, okay, well, what's the reciprocal of 0? Or what's the multiplicative inverse of 0? And you think, well, how can I write 0 as a fraction? Well, I could write 0 as a fraction as 0 over 1, right? Is there a problem with this? Well, no, there's not yet, because the 0 is in the numerator. Remember what we learned in lesson 9, I believe it was. If the 0 is in the numerator, we're okay. 0 divided by 1, there's an answer to that. It's 0. Okay? If 0 is in the denominator, then we're in trouble. So here, 0 is in the numerator, we're fine. But what's the reciprocal of this? Well, what did we just say? To find the reciprocal, you have to flip it. So if we flip it, we have 1 over 0. Now we have a problem, because the 0 is in the denominator. And if it's in the denominator, as you recall, this is undefined. There is not an answer to this. Okay? So anytime we end up with that 0 in the denominator, we're in trouble. So what do we say then? If someone says, find the reciprocal for 0, the answer is there isn't one. All right? There isn't a reciprocal for the number 0. It's the only real number that we don't have a reciprocal for. Any other number, you go ahead and pick any number you want, it's going to have a reciprocal. Even a negative number. I mean, I can have, what's the reciprocal of a -2? A -2, well, we write that as a fraction as -2 over 1. And the reciprocal, we just flip them. So now it's 1 over a -2. And I can move that negative to the outside if I want and write that as a -1/2. Okay, that's the reciprocal. So negative numbers have reciprocals as well. All right, the only one that doesn't is 0. 0 does not have a reciprocal. It does not have a multiplicative inverse. All right, very good. So hopefully that makes sense to you. Let's move on here to the next part of our lesson, which is we're going to start working a little bit on order of operations. So we're shifting gears here for a second, and we're going to talk about how to multiply and add numbers again. So let's say I've got the problem or the expression 6 plus 2 times 4. All right, and I asked you to find the answer to this. So go ahead and just take a minute, and if you can do it in your head, great, but just try to come up with the answer for this. All right, well, you may have noticed that you can come up with several answers for this. So if I were to say, okay, let's start by just beginning at the left and working our way to the right, we could say 6 plus 2 is 8. And now we've got 8 times 4, right? So 8 times 4 is what? 32. There's our answer. Pretty straightforward. But let's look at this again. What if I've got 6 plus 2? I'm just rewriting it here. It's the same problem. And now we work it a little bit differently. Let's start from the right side and move to the left side. So we've got 4 times 2, which is 8. So I'll just write that here. And then I have this plus 6 left over. Now I've got 6 plus 8, which is 14. So all I did was do this part first to get this 8. Whoops, it's a terrible arrow. To get this 8 here. And then I have the 6 left over here. So that just moves down to here. So I've got 6 plus 8, which is 14. Now, that's my answer. But if you look at this, they're not the same. 32 is not the same as 14. So what did we do wrong? Or better yet, which is the right answer? All right. So the issue here is both of these are, in a sense, correct. We didn't do anything wrong in our multiplication and our adding here, but we ended up with different answers. So throughout the years, mathematicians have decided to basically standardize how we do this. In other words, they've created a rule on how they want you to do problems where there's both addition and multiplication, because they are not really commutative. You can't switch the orders in which you do these things. All right. So the rule that mathematicians decided was when we perform these operations, we always do multiplication first. We do multiplication and then we do addition. All right. So looking at this problem, I'm going to rewrite it one more time. 6 plus 2 times 4. We see that there are several operations here. We're adding and we're also multiplying. We're going to do the multiplying first. So we take the 4, we're going to be multiplying that by the 2. Now, whenever you think of these things, always make sure that you include the sign with the number. All right. So you might think of this as a 6 plus, and then I'm just going to put a plus 2 times 4. Okay, so all I'm really doing is just taking this part and doing it first, the plus 2 times 4. But I have to remember that 6 is being added to that. All right, remember we're always adding in algebra, always adding. Okay, so doing the multiplication first, we have a positive 2 times 4, which is an 8. And then we have this remaining 6 plus. 6 plus 8 is 14. So the correct answer is going to be the 14 over here. And this one was right because we did the multiplication first. All right. So let's try another problem here that's maybe a little bit more complicated. Let's start, well, let's see, where should we do this one? Let's do it up over here where we have a little bit of room. We're going to do 3 minus, and we'll go, well, let's see, minus 2 times 5 minus 8 times a negative 9 minus 3 times a negative 10. All right, so this is a pretty, extensive problem here. The first step is going to be to find where the multiplication occurs. So if we look at the problem, let's find multiplication. So we have multiplication going on between the 2 and the 5 here. And keep the sign with it. Negative 2 and the 5. Where else do we have multiplication? Well, we have a multiplication between this negative 8 and the negative 9, right? And we have multiplication between this negative 3 and this negative 10. All right. So let's start with doing the multiplications. Now, don't forget this 3 is being added to everything. So we've got this 3. Think of it this way. Maybe we'll do, we'll put that in black since that stays the same. And then we'll do in a different color here what we've done here. So we have a 3 plus. Now let's do this one. What's a negative 2 times a 5? Hopefully you said negative 10. So we'll just kind of put that in parentheses. Just kind of set that aside. Then we have our plus again, because these red boxes are all being added together. Plus. And now we have our negative 8 times a negative 9, which is a positive 72. And then we have our plus again for the last box here of multiplication. We have our negative 3 times a negative 10. And what's negative 3 times a negative 10? Well, hopefully you said 30. Remember, a negative times a negative is a positive, 30. All right, so now we've done all of our multiplication. All right, now we can do our addition. That's the next step in our order of operations here. So if we move on, we could say 3 plus a negative 10 is what? It's a negative 7. So we have a negative 7 plus our 72 plus our 30. And I just removed the parentheses here. We no longer need them. So negative 7 plus 72 would be what? Think about that for a second. Hopefully you said 65 plus our remaining 30. 65 plus 30 would give us our 95, right? So the answer then is 95. So again, think about what we did. We first located the multiplication, did the multiplication, and then added everything together. All right, so let's try another one here. What if we've got, let's see. What if we go 2 plus 6 times 2 plus a negative 3 times 5 minus 2. All right, go ahead and try to solve this one. Maybe take a piece of scratch paper and just take a minute here, pause the video, and see if you can come up with the solution for this. All right, so hopefully you've gotten your solution now. Let's go through it together and see how you did. So we're going to start by finding the multiplication. So where is the multiplication in here? Well, we have this positive 6 times the 2. That's multiplication. Parentheses that are right next to each other like this indicate an invisible multiplication sign between them because there is no other sign. So that's going to indicate multiplication. And that's it. Those are the only two places. So we end up with 6 times 2. If we compute that, 6 times 2 is 12. It's a positive 12 because we have a positive 6 times 2 is a positive 12. So we have our original 2 plus now the 6 times 2, which is our 12, right? And then we move on. We have plus, now what's our negative 3 times a 5? Hopefully you said negative 15. We'll just throw that in parentheses so we don't have two signs right on top of each other. And then we have our leftover negative 2. So now all the multiplication is done. Now we can go through and do the adding. So if we've got 2 plus 12 is 14. 14 plus a negative 15. All right, so remember how we do this addition with negative numbers. 14 plus a negative 15. All right, that's going to be what? Negative 1, right? Plus our negative 2, which is going to equal negative 3 as our final answer. All right, so that hopefully is what you got on your scratch paper. If not, look at what you did wrong and make sure you understand what you did wrong. All right, let's try another one here. So let's say I've got, let's go with a 3 times 5 plus 2 plus 4 times a negative 2. All right, so once again, pause the video and try this one on your own, and then we'll make sure you got the right answer. All right, so hopefully you've got the answer down on your scratch paper. Let's see how you did. Find the multiplication. Where do we see multiplication in here? Well, I see it right here, the 3 times the 5. And then I see it here because, again, this is an invisible multiplication between that 4 and the parenthesis. So I see a positive 4 times a negative 2. That's where I'm seeing the multiplication. So let's start with that. What's the 3 times the 5? The 3 times the 5 is 15. And then I have left over from the original problem here, I still have that plus 2, right? Now let's take this positive 4 times the negative 2. A positive 4 times a negative 2 is negative 8. So we have negative 8, right? All we just did was the multiplication. Now we can go ahead and do the addition. So if we do the addition, we have 5 plus 2 is 7. 7 and a negative 8. Think of it in terms of you're 8 in the whole, and now you have a positive 7 that you're adding to that. Now you're only 1 in the whole, so you have a negative 1 left over. So that would be our answer. Okay? So hopefully that's what you got on your scratch paper. Let's try another one, because I know how much you're having fun with these. Here we go. 13 minus 4 times negative 5 minus 3 times a 10. Okay, so pause the video, try that one. All right, so you've hopefully got the answer there. Let's look at our multiplication. Where do we see multiplication in here? Well, I see it right here, and I see it right here as well. Right? Now this one, hopefully you didn't make this mistake, but this can be kind of tricky for people when they're beginning here. We're not taking 4 times a negative 5. All right? We're taking a negative 4 times a negative 5. There's a difference there. We have to keep the sign with the number. Sign always stays with the number. All right? So we have a negative 4 times a negative 5. So a negative 4 times a negative 5, a negative times a negative is a positive. 4 times 5 is 20. So we have this 20, right? And we still have, though, our 13 from the beginning. 13. And we're going to add the product here of these numbers, which is the 20. Remember, we're always adding. So 13 plus 20. Now I've got over here I'm going to add the next product, which is this negative 3 and 10. So what's negative 3 times 10? Hopefully you said negative 30. Now I might just throw that in parentheses so I don't like seeing two signs right next to each other. So we'll throw that in parentheses, negative 30. So what do we end up with now? We can add 13 plus 20 is 33. And then 33 plus a negative 30. So 33 plus a negative 30, which would be the same thing as 33 minus 30, right? 33 minus 30 is a 3. So our answer here is 3. All right? So hopefully that makes sense to you. Let's see, how many did we do? Yeah. If not, we can go over this on Wednesday or ask me questions in the OneNote page for questions. But essentially what you need to remember to do is to always do multiplication first and then do your addition. All right? And then I would just add to that. Don't lose track of your signs. Keep the signs with the number and add the products together at the end. Okay? All right. Well, very good. I think that concludes this lesson. So go to your OneNote notebook for the homework, and you can start working on that. And I will see you tomorrow.